Hello, everybody. Welcome to Migration Training Module 2, Supercomputing File Systems. I'm Pascal Elahi, and I'm going to be taking you through the new file systems as well as how to transition to these new file systems on the upcoming supercomputer. So this is Module 2, as I've stated, in a 6-module series describing how we are helping you migrate to the new Setonix supercomputer and the related infrastructure. The learning outcomes for this module is to be able to compare the file management approaches on Setonix and pre-Setonix systems, monitor file system in use and size, familiarize yourself with the file migration pathways and use cases, review recommended changes to data workflow, familiarize yourself with changes to reference datasets, and review Pawsey's policies and best practices for this data. And there'll be a discussion also on the data security considerations and best practices. Now, file systems at a glance. So the current file systems, the pre-Setonix file systems, are home, group, scratch, Pawsey, and a few Astro-related file systems. The purposes vary. So they're meant to be for specific purposes. So home is used to store configuration files, stores user configuration files, and group is to store project maintained software and associated scripts for that software, and project data. And by project data, I mean reference data sets and data sets that are produced that are meant to be kept for project like timescales. Scratch is for storing working data, the data you need to actually run your jobs. And Pawsey currently is used to store Pawsey maintained software and also store some radio astronomy project data. The Astro file systems, ASCAP buff and ASCAP extend, these astronomy specific file systems are used for a variety of things, such as storing software and project data. Now, those are Astro specific. So for most users, they would not necessarily have interacted with these file systems. But if there are some questions later on, perhaps we can discuss it. Okay, what are the changes to the file systems for Setonix? So we are trying to simplify the file systems on Setonix. So software, where you're going to actually store your software, it's going from group and Pawsey / home, which we do know sometimes is used to store software, and / Astro. This is all going to software / software. Project data similarly is distributed across multiple file systems currently in the pre-Setonix file systems under group, Pawsey. We do know that Scratch is also used sometimes to store project data, Astro, and there's also the tape systems, HSM. This is all going to be amalgamated into the cacia storage system. I will discuss cacia in a bit. You will have been introduced briefly to the cacia storage system. Working data, the data that you use when you're actually doing compute, is typically stored on Scratch. We do realize that sometimes this data is stored on group or Astro. This is meant to be amalgamated, and Scratch is going to essentially go to Scratch. So we'll have a new Scratch file system. Configuration files would typically be stored on home. We do realize that sometimes it's stored on group. This should be located on the new home file system. And you'll see this repeated in terms of a color scheme. Gold is new infrastructure, and white in any figures you see is existing infrastructure on the current pre-Setonix systems. If you do see brackets, it is that the usage of that file system in this particular type of, let's say, type of data is not recommended. So file system details. Let's go through these new file systems. So where will software reside? So the current or pre-Setonix distribution of software is a cross group for usually project and user-specific software. Pawsey / Pawsey stored, Pawsey maintained software. Some software we do know users has had it stored on home. This is not recommended. And Astro also stored software across the current systems of Magnus, Galaxy, Zeus, Topaz, and Garawala, which is an astronomy-related supercomputer, had access to Astro. This will eventually be amalgamated into / software. The software that was previously going to be many is now going to be amalgamated to one. And the software file system, it will contain programming environments, libraries, and tools, domain software maintained by Pawsey, user-maintained software stacks, and any files related to workflows, such as bash scripts or producing bash scripts. And I'll rewrite the legend here again. Gold is for new infrastructure, white is for existing infrastructure, and red is for astronomy infrastructure. And anything you see in brackets is usage that we do not recommend. So what is /software? Well, /software is a high-performance parallel Lustre file system. It will have a 256 gig quota per project and a 100,000 file limit as well. So it is able to store reasonable amounts of data, but is not designed to store project data or working data that could be very much larger than 256 gigs. The data is retained for the lifetime of the project, i.e. the software that you install in the software stack is retained for the lifetime of the project. And it is organized as follows. There is a project-wide level, so that's /software/project, the project being the project ID. There's also the user level, which is /software/project/username, and that can be accessed through the my software environment variable, provides a quick shortcut. More details of the software stack and also its use and what will be in the software, in this /software can be viewed on the documentation and also in modules 3 and 4. Now, once you have software, you have obviously you're going to produce project data with that software. Where does this project data reside, and where should it reside when Setonix is up and running? So in the pre-Setonix era, there was tape storage that was accessed through Zeus, and then there was Scratch, Group, and Pawsey that were used to store project data, with Group and Pawsey being the recommended places for storing this project data. Astro as well was accessible through Garawala for the astronomy community that also stored project data. Now, what this project data is meant to persist for the lifetime of the project and includes project-specific reference datasets, calibration datasets, things that are really meant to retain and be unchanged to some extent for the lifetime of the project. This is, as I said, was previously located on Mini and now should be located on Acacia, the new object storage system. The old group file system will be temporarily available as old group on the Setonix copy partition. So you will be able to access, while you're migrating, group and move stuff from /group, accessible through old group, and move it to Acacia. Now, I've mentioned Acacia several times now, the Acacia object storage system. Now, this is a high-performance, large-volume Ceph object storage system that can be accessed using the S3 API, this S3 interface. It is used to store project data for the length of the project, and projects, and in terms of the merit allocation projects, will be given a terabyte of project-wide allocation for Acacia by default. So this is a terabyte shared by all users, all researchers within the project. This can be increased to 10 terabytes upon request via help tickets through the service desk, but larger allocations must apply separately. So if your project requires larger storage than 10 terabytes, this will be accessible through the online web interface for accessing, for just putting in a form essentially and asking for more storage. The interaction with Acacia is covered in module 6, and this will provide you an overview of how to move data to and from Acacia. We won't focus on that here. Now, where will working data reside, right? This is the data that you use to actively do compute. Pre-Setonix wise, this was principally on Scratch, though occasionally Group was used to store working data. And for the astronomy systems like Garawala, there was also Astro used to store Scratch data, essentially data that was actively being produced or read. This will be amalgamated into just Scratch, and Astro will be retained for some working data for the astronomers. The old Scratch storage system will, again, like Group, be available as old Scratch on the Setonix data mover nodes, allowing you to move from old Scratch to new Scratch, right? So they share the name Scratch. They are separate file systems. And to reiterate it as well, the Scratch data should be any data that is actively being read or written by jobs that are going to be queued or running or recently completed. And the idea is to stage data onto Scratch before you're going to run your jobs. And then once jobs have completed, to migrate data off Scratch and to either Acacia storage or the appropriate storage off-site, off Pawsey systems. So the properties of Scratch is very similar, if you will, to the current Scratch system, pre-Setonix Scratch. It's a high-performance parallel Lustre file system. The Setonix Scratch will have a 1 petabyte capacity per project and a quota of 1 million files, and with the 30-day purge policy. So there's quite a lot of available storage, but is for short periods of time. The file system is organized very similar to the software storage system in the sense that there's /scratch/project for project-wide data, and /scratch/project/username for user-level working data. And this can be accessed through the my_scratch environment variable. More information can be provided at the Pawsey file systems and their usage. So configuration files, pre-Setonix wise, there was a /home that was mounted on all pre-Setonix systems. You could access it through Magnus, Galaxy, Zeus, Topaz, etc. The software that was also used custom configuration settings. So there could be Python, even the shell, bash shell, has configuration files, and this would be best stored in this home directory. It's either .bash for, let's say, a board again shell. These are examples. .vimrc. They currently are stored on home. They should still be stored on /home. This will be a new file system, however. So home will be new, and it can be accessed on the new Setonix system via old home. Other examples of data types that should be redirected away from home is software installation. So occasionally people were installing software in home. They should be definitely moved to software, and temporary data should be moved to scratch. And any workflow specific configurations you're going to use often, such as scripts that could be the basis of SBash scripts or SBash scripts themselves, should be actually placed in software and not on home. So the properties of home is it's just a simple NFS file system, and it's not designed for large-scale parallel access, unlike the other file systems, which are lesser parallel file systems, high-performance file systems. There's a 1 GB quota per user and a 10,000 file limit per user. So the limits are such that you will not be able to store large amounts of files or a large number of files or large amounts of data. As I mentioned before, home will be available as old home on the Setonix data mover nodes, and can be accessed via the shortcut /home that will take you to the system. This home will be accessible on all file systems. But again, I'll just read it because I mentioned it before. Though it shares the name home, it is not the same home that you would see if you logged into Magnus when you're migrating. So any changes you make when you make to any files that are in /home on Setonix will not be reflected on changes you see on Magnus. And it's something important to remember on the file systems that share names, but they are different file systems. So more details of their Pawsey file systems and the usage can be found on our documentation. To kind of narrow in on the impacts on certain systems, right? So Garawala and Topaz, which will continue to exist in phase 1 of Setonix and will possibly continue, Garawala will exist past phase 2. They're currently using some of these file systems, right? So migration of home and group will impact Garawala and possibly Topaz for the people who are using those systems. The Garawala migration will occur following the completion of the initial stage of Setonix migration, and will be done with the consultation of the MWA team because Garawala has some astronomy-specific file systems. Topaz migration, if you have any Topaz-specific software, anything that would require GPUs and NVIDIA GPUs that are accessible through Topaz, its migration will be contingent on the phase 2 GPU deployment of Setonix. These migrations will involve transfers of files onto a new file system, similar to the migration that we are discussing here in the following slides. So a summary of key changes. So existing file systems, the /group, which was meant to use to store software, will now be /software, which is hopefully less confusing. And the idea is is the file system to store project-wide specific software data. So if users have project-wide specific software, or even if it's their own software, this should be located in /software. It's meant to provide a permanent access for software and it's meant a central location to simplify setup. And it may require fresh installations of domain software by project groups if there are updates to the hardware. Group, in terms of project data, that is now meant to reside on cacia. And so cacia is an object storage file system, and it's meant to store this project data, this project-length data. It provides a large volume project scale object storage that's accessible via S3. It does require explicit management of data using Scratch to stage. So in the workflows, you'll have to start staging data from cacia to Scratch. It's not a simple copy command that you might have used before. And it will also require migration of files from old group or group. right? The old group data. Scratch is moving to Scratch. Its purpose is unchanged, right? It's meant to provide fast, large volume work storage. The new file system is larger and is faster and will require migrating files from old Scratch if you have files that you want to retain for jobs that are going to run. Home is going to move to Home. Again, its purpose is unchanged. The file system is designed to store configuration files and will require or possibly require migration of files from old Home. Slash Pawsey, where we were the Pawsey provided software, right? Stored software. This Pawsey maintained software is now going to be in slash software. And again, will be migrated by the Pawsey staff. And so you don't have to worry about that particular migration, but modules you'll see will change where they point to the software. A slash Astro, specifically for data that is software, so executables, libraries, and so on, that should be migrated to slash software. And the migration of this project managed radio astronomy software will be done in consultation with MWA. And the project data that currently resides on slash Astro should also be migrated to Cacia, similar to the working data that was on slash group. And again, this will be done in consultation with MWA, which is the primary user of slash Astro. Migrating data to Setonix. So the migration of data, because it's going to obviously go from a large collection of file systems to a slightly smaller number of file systems, will require some planning. Each file type that's already been discussed, and you should consider where files should go on the old file system and where they need to reside in the new file system. So configuration files should go from old Home to Home, but the Setonix Home. Again, I will reiterate, any changes to make on the Home accessible through pre-Setonix systems will not be reflected on the Home in Setonix, and so must be explicitly migrated via copy commands and SCP commands to this new Home. Working data from old Scratch or group, though not recommended that it should have been on group, but the idea is that you could have had working data that's on group. That should be all migrated to the new Setonix Scratch. Project data should be moved from group to Acacia, and any Slurm batch scripts, anything that's kind of related to running workflows that might have resided on Home, Scratch, or group, that should all be moved to software. You will have to reinstall software, right, with newer versions where appropriate, instead of just moving it. So you cannot copy an executable that currently resides on, let's say, group. The idea would be to copy the source and rebuild that software because of the new hardware. Any files that are not actively needed, right, should be moved to institutional storage or deleted. They should not reside on the current, the new Setonix file systems. And more details about migrating data can be found in our documentation. Migrating your data to Setonix. So existing file systems, as has been mentioned previously, will be mounted temporarily on the data mover nodes of Setonix to support the migration. So with the prefix old. So Home will be old Home, group will be old group, and Scratch will be old Scratch. And for smaller files transfers, if it's a few files or not particularly large files, you can use an interactive session through SLOC to copy, to get access to the copy partition and just manually move files with the move copies and so on. The recommendation is to create Slurm batch scripts for larger files. So you can automate this process by using the copy partition and using sbatch to submit a job. We would recommend using tar to combine and compress large number of files. If you have large number of small files, it's much easier to move those large number of small files by first compressing them and tarring them into a single file, and then moving that tarred file and then expanding it out on the new file systems. For complex directory structure, where you'll have maybe large directories which contain large number of files and possibly large number of data, the recommendation is to use multiple tars per directory so that it is, the process is a little simpler when you then unpack those tar files. We would recommend the use of rsync when you're resuming the transfer of large number of files. This command will automatically check if a file has been copied, and if that file has been copied, not recopy it. More details can again be found on the migrating data with Setonix documentation. So migrating your data, we'll provide you an example bash script for copying a large number of, let's say, small files that could be amalgamated into a tar, or some very, very large files. So the idea here is to put in a bash script where you access the copy partition on Setonix, as you can see highlighted in partition equals copy, request the needed amount of time and the number of resources that you need. Typically, this would not be limited to computational resources. You would limit it to possibly one node and one CPU. And then you would provide the path that you're going to use, the old path and the new path, and then copy this directory or these files. As I said, for directories that contain a large number of files, so the suggestion is to actually go to the old directory, tar it with this command, tar, and this compression command that will create a tar file that can be then more simply copied in one swoop onto the new file systems. So transferring data to Setonix. So best practices. I've mentioned a few, but it's good to, again, go over it again. Do not transfer a large number of files. So if you're transferring hundreds to thousands of files, we recommend the use of the tar command to pack files into an individual single file for transfer. Use the data mover nodes when transferring large amounts of data. And the data mover nodes are accessible through either the current data mover name, you'll recognize the name datamover@pawsey.org.au, or through the copy partition, where you can access through the scheduler. Please review the data storage and management policy. It tells you how to move your data and what to do with the data. And we have documentation on transferring files on our documentation. Transferring data, so remote access. If you are going to try to access the data via external systems, the idea is to realize that the Setonix file systems are externally visible via the login and data mover nodes. So you can just transfer data, large files of data, so large number of files or large transfers using the data mover nodes by using datamover@pawsey.org.au. It just avoids congestions of the login nodes if you're just going to do explicit just data transfer. The clients that are available will depend on your terminal environment, but the examples should be SCP and rsync. They should always be available. And you can also use a GUI client as well. These would then access the data mover, data-mover.pawsey.org.au system through system clients such as MOBA, Xterm, FileZilla, WinSCP, and CyberDuck. And we have documentation on using GUIs and on using the command line in our transferring files documentation. So for interactive sessions, if you're going to transfer data using the Setonix data mover nodes in interactive sessions, this is really meant for small data transfers. So you can access this by using SLOC, gain access to the copy queues of the data mover nodes, and use command line programs such as SCP and rsync to just move files from the old file system to the new file systems. The remote access to external file systems will be needed for the transfer. So if you are going to transfer to external stuff, you do need to have this remote access. The data mover nodes are suited for transfers between centers or institutions rather than laptops. So if you're copying from, as I said, if you're copying from Pawsey systems to external systems for external storage, long-term storage, this is how you should do this. You should access the data mover nodes. You can use a bash script. Again, you would use the copy partition. And again, we recommend using tar to combine and compress a large number of files before beginning the copy. Again, more details can be found on transferring files in the supercomputer documentation. Now, for data workflows. With the new file systems, this will impact how you actually use data in your workflows. And this is an overview of what could change. So the data workflows pre-Setonix. The diagrams indicate the possible paths, all possible paths for data to flow, eventually for Scratch, right? So to Scratch, so they can be then used to do some compute, do some processing. So you would pull data in, possibly from external sources. You could possibly pre-process some of the data, and then you would run a job on Magnus or other file system, other systems like Topaz or Zeus Galaxy, producing data on Scratch. And we do recognize that some users were producing on group, but this is not recommended and will not be possible in the new file systems. Moving data out could also involve quite a plethora of file systems accessing Scratch, and with many possible paths taken. So you could run a job on Magnus, produce data, and then move it from scratch by launching a copy queue command on Zeus to copy data to tape, or maybe for storage outside of Pawsey. And if the data was required for later usage, is now produced as a reference data set, you could move it to slash group if it was small. So what are the changes? So if you look at the diagram on your left, you can see the pre-Setonix flow of data. And on the right, you can see the Setonix paths that are taken. So you have the world, you have the cacia, and you have data mover nodes talking to the Scratch file system that's accessible through Topaz, Setonix, and Garawala. So the workflow changes are meant to be, the file system is also meant to simplify the flow of data to and from Pawsey systems. So in this case, if you had external data, you could access it directly via the data mover nodes that would then copy it directly to Scratch for use by the Setonix supercomputer or Topaz or Garawala. Or it could also be stored on Acacia if it's meant to be for project length storage that could then be pulled in as necessary for work. Flow of data from Pawsey. Pre-Setonix, all systems could access Scratch, right? So there could be different systems being used to then move data to the data mover nodes that existed on Zeus to then copy to the tape systems or the world, the outside world. Things could also copy directly from Scratch to the group file system for storage, if it's meant to be for project length storage. This is now somewhat simplified on Setonix, where you have the Scratch file system accessible through Setonix, Garawala, and Topaz. They would use the data mover nodes to then move data to Acacia or the outside world for project length storage. So the key changes is what we hope is a simplified flow of data. So management of data and workflows will be simplified since the data mover nodes are part of Setonix, unlike the previous setup where the data mover nodes are part of Zeus. So if you were not using Zeus, you would have to know the usage of 2 supercomputing systems. HSM and group will be replaced by the Acacia storage system, which provides a large volume project length storage. So you have 1 system as opposed to 2. The data mover nodes, as they are part of Setonix, you don't use different clusters to move data. And so they can be a simple unified setup in the workflow. The data mover nodes are available via the copy partition in Slurm or externally via the datamover.pawsey.org IP. So more details on data workflows and the key impacts of the changes can be found on our documentation. Now, reference data sets. Not all researchers have reference data sets, but there's enough that do. And the reference data sets are meant to be project length reference data sets that are used as part of the workflow, but need to be retained. So reference data sets are commonly used in a large number of research fields, but not all. Pawsey staff make them available to avoid having multiple redundant copies of this reference data. On Setonix, each data set will be contained in a subdirectory on the /scratch/reference/ subdirectory. This particular subdirectory is not, it doesn't have the purge policy in place. So it will be retained for the length of the data being used. So if the data is being used by any given research field, it will be retained. Examples are /scratch/reference/ASCAP for radio astronomy related to the ASCAP telescope. There's also something similar for the MWA telescope. For bioinformatics, an example would be /scratch/reference/blast. More details of these reference data sets can be found on our documentation. The key thing is that we are going to try to best to amalgamate these reference data sets that are used in multiple research fields into one place with the on Scratch. So it makes use of the high speed storage, so the high performance storage, but is not subject to the purge policy. So a quick review of the Pawsey data policies and practices. Proactively monitor file system usage, both in size and number of files. Remember that there are quotas on both the size, the amount of storage that is used by users, and the number of files. We recommend reviewing files on the old file systems and only transfer files that are necessary to avoid sort of bloating the file system immediately with files that you haven't used in quite a while. Transfer files to the appropriate file systems and folders. This will be possibly a bit of will require some analysis of slash group probably for most projects where they decide what data should go where, such as deciding whether some data is software or some data is reference data sets, and so should be moved either to cacia or slash software. Do not forget that there's a 30-day purge policy on Scratch. So if you have data that is going to be currently used and is being used, but the migration policy might be such that it might not get used again in 30 days, perhaps move it to cacia first before pulling it to Scratch and making use of it there, and possibly cleaning up storage on Scratch. On cacia. So please be aware of the file system policies. For cacia, the new object storage system, there is specific documentation for the best practices of cacia, and we have documentation also on using cacia within workflows. More details can be found at the Pawsey file systems and their usage. Now, how do I get help? The help has not changed. We have documentation, but the documentation specific pages have changed. So there'll be a Setonix migration guide, there's a Setonix user guide, and there's a supercomputing documentation. We will have migration training materials and videos recorded, such as this video, to be used for upgrading migration training, and also to review once migration training is completed and you just want to refresh your memory. And there's also always the help desk that you can use for specific issues that you're having, edge cases and so on that you're having difficulty dealing with. Thank you for your time. I hope the migration goes well.